Okay, 745 prefix and suffix search. Given many words, words sub I has weight I. Design a class word filter that supports one function, word filter.f, with the name of the function. It will return the word with the given prefix and suffix with maximum weight. If no word exists, return -1. And I drank too much iced tea, I think. Okay, so you have some examples. What is this? Zero means, oh, because this index is 0 and this is, I guess 0 times 5. Oh, no, it's because this is the index 0. What a weird way of phrasing this. Because you just want the, with this weight is just basically what you're asking is just you want the last word with the prefix and the suffix that match. Okay. Let's look at the constraints. Words has length of up to 15k for each test case, up to word start length. So you could do 15k queries. So they probably want you to do some pre-processing. Word sub I has, so there's only up to 10 characters. That's not bad. Prefix, suffix have lengths also up to 10 characters. Word sub I and prefix, suffix consist of lowercase letters only. Okay. Hmm. How do I want to think about this? I mean, so where you are, I guess I should articulate my random thoughts. But in general, whenever I see kind of these kind of string forms, I think of prefix tree or suffix tree. Well, no, well, I guess I think of both, and then kind of think about it a little bit. And then, yeah, hmm. Yeah. So a prefix tree also is known as a try. I think that should be sufficient. I'm trying to think why that would not be the case. And the bulk of the work will be done in the pre-processing. I'm trying to also maybe think about what language I would like, but maybe Python should be okay. Um, hmm. This is pretty basic problem, or basic in terms of I don't like there's no tricky nuances. It just tells you stuff. Uh, okay, I mean I think what I want to do now is just kind of build a try of all the prefixes, and what would that cost? Well, each word can have up to 10 characters, so your try will only be 10 levels deep. Uh, yeah, I think that's, and you have 15,000 words, so you're going to have only about, what is it, 150,000 nodes times two, the other one for the suffix, and then you kind of just walk the try to kind of, and then return the latest step. Um, yeah, is that sufficient? Yeah, that should be okay. And each of them just contains the maximum weight at that given level, and you just go for all the words. Yeah, I'm thinking. Let me know if I need to explain a little bit more. I'm going to stop implementing, and hopefully that'll show what I mean. But I could, and I would say if I was in an interview, I would kind of maybe draw out some of these diagrams. But this is actually like literally there is a thing called prefix tree. So like uh, I don't know if there's anything that nuanced that I have to explain other than that. You just kind of program it. Okay, but something like that, and then we pre-process a word. We just have a root. We probably have to define a new data structure. Just for try, just for fun. I know how to do this in regular Python, but I don't think I've done something similar in Leetcode Python. So I don't. So hopefully we'll see. What that one there? I guess in here we want the value. Maybe we don't even care about that. Oh wait, but can we just have a dictionary? It's probably fine. Yeah. Okay. I think this might actually be the first time I implement a try from scratch in Python, so we'll see how that goes and see how much I remember about the nuances of tries. But okay. Actually, let's see if this compiles first. Also, maybe what? Too soon. It's only 2 in a row. But also, it seems like this is Leetcode slightly faster, which I'm happy about. Okay. Okay. So how that work then? Well, for this is probably not going. Yeah, let's stop that. Okay. Oh, no, I need to keep the rate. Okay. So this should be a good start. Yeah, I need better ergonomics for this desk, but okay. I guess that's all the pre-processing now that I think about it, possibly. So let's just play around with how do I want to visualize this? Yeah, maybe it's okay. Okay, I'll just walk this tag. Walk this try. Oh, and so this is only for the prefix. We'll have to create the exact same one for suffix. So maybe we have to process it in a. Actually, maybe we have to store a little bit more. Maybe in this case we actually have to store all the weights instead of just the best weight, and then we have to do a set intersection. Yeah. Okay. Yeah. Okay. But I'll do this after I get the prefix, so that I could kind of at least convince myself that this works first. I guess it's more like set edges. That's not even right. This is a little dirty in terms of OOP. Yeah, maybe I should just do it. Okay, fine. I have to kind of do that. Okay. We add a little bit more test cases for test. So the second one should actually give me, well, -1, but that's just coincidence maybe. That I get the right answer because I don't even do anything about a suffix. Oh, no, now it's slow again. Sorry friends, Leetcode is being slow today. You just tune in, so spending a bit of time waiting for testing to go through. Okay, so I mean, this is definitely coincidence, but I mean, we could confirm it by let's say app, and then well, let's try one with, and then another one with a non-sensible one. Okay, so the output is what I expect it to be. I mean, it's incorrect, but it's what I expect it to be because we didn't do anything about suffix. That's good, at least. It means we're on the same right page, having or the right track. But as I said, just covering the weight is not good enough because now you have to kind of take the best of the suffix and the prefix. So now we have to, this should be a set. Yeah. I think the other thing that I'm trying to think about is also, well, that was said, then how much less efficient it is. Well, because it should be, well, it makes the space storage, the space complexity, about 10 times bigger, because each character would, so instead of, so we have 150,000 nodes, but instead of each of one of them containing only one int, now each of them can contain, well, a big number of ints, but because each word can only have 10 characters, the total number of characters was like, so it only appeared 150,000 times, so it should be okay. It just might have to think about it in terms of analyzing. Yeah, because you set. So now it should give us the wrong answer, but well, we only have one word, so actually there'll still be the wrong answer, just not because it doesn't return, because it returns a set instead of whatever. Now I added more words so I could just see if it'll give me. Yep, okay, that is actually what I expected to. Okay, for me, what I like to do is, if given the opportunity, just test myself iteratively, even though the answer will be wrong, just so that you don't want to get so far deviating from the correct thing that you have to like figure out where to debug with. Like now I have almost like a weird version of TDD where like I know that what I have is currently what I expect it to be, and then we could make the next steps. And what we have now is that we only have the suffix, but not, oh, sorry, the prefix, but not the suffix. How do I, there are probably two ways to think about how to construct it. The suffix version, you could probably, I mean, so yeah, so the one way is kind of just like add it on top of this thing. And then the other way is to create a separate set of tree nodes, which I think that's what I do, just to kind of make it less confusing. I have to rewrite some stuff though. I think I did get this case. Oops. Let's see. Let's double check that that works first. Okay, still should the same answer. Where did I go? Oh. Let's actually just do -1. I wish that more example of suffix because I actually just want to make sure that it's actually in the right order. Let's just print this out. So this is, well, I guess that's not right. It should print out something twice. This case is correct. No, in that case, it's not even correct. That is suffix one. Oh, that's why. Oh, yeah. That's what happens when you copy and paste. Also, what the? There's wrong. Okay. Oh. Huh. What am I doing? Okay. Reverse. Is there not a string reverse thing? We don't actually need this. I just see it as a source of possible confusion, so off by one is. Okay, so this does return stuff, and actually should return the right answer. Is that it? Or am I thinking of a different way to do it? Now we have to get the biggest one, if that's the case, okay. Okay. One thing I worry about is that I don't think actually I test this enough for suffix. Let's do at least a couple more. Ooh, okay, that's good that I have a bad one. But let's see what? Because on root node, I don't add anything on root node. Okay, so actually, glad that I tested this. I've actually been meaning to. Because we don't, on this function, we don't set it at all. But how do I do it now? Sure. So now it should be rate, but so that's late. So okay, so that's right. I think I need to test one. Well, I would like to test something that doesn't return 0. So let's maybe just open that for general. That's probably give an issue because I missed a few. Okay, okay. I just submit and see how it goes. Oh, now time limit exceeded. Okay. Uh, hmm. That's wow. Okay. I guess this should time limit exceed. Okay. Um. So I think I would just mostly lazy. Um. hmm. Okay, that's not so bad. I think what ends up happening is that yeah, it so this set in this section is too expensive to do per query, so we just have to kind of what you would call it. Well, we have to do it as part of the pre-processing then. And, how do I want to do this as part of the pre-processing? Um, just thinking about how to do this in a quick way without kind of rewriting a lot of code. And I think my first intuition is to just merge the nodes together. But, and we could also maybe maybe just pre-cache this. But, yeah, I mean, I think what I'm going to do is just a variation of the memorization, maybe. Now I think I'm okay. I'm just going to pre-process the entire thing again. and I just do it recursively. Yeah, so the weight of a word is no, I mean it's very easy to miss actually because I've messed up earlier. But yeah, the weight of the word is for words in the ith entry of the array, it has the weight I. So it's just a sentence, but it's very easy to miss for whatever reason. Also, welcome back now too. um, but yeah, but that's how I kind of you kind of look at it. Where do I have it? The pre-processing. That's why this is kind of just the ith index of the word array, and that's why we're treating that as the weight in general. At least in Python, maybe it's a little harder to read than maybe other languages. In this particular instance, the enumerate returns the index and the actual item in the thing, and in this case, it just also happens to be the weight. But yeah. Just walk the prefix file, okay? And then now we want to do this recursively for at least the prefix. So we only have to do it for one of the things because if it doesn't, maybe not actually, we'll see. I have to do this in a cleaner way. Wait, does this make sense? No, what am I doing? I don't think that what I'm doing is right, sorry. Why am I combining these like this? Okay. What I'm doing didn't make sense now that I think about it because these things are not on the same word. Why is this time? Shut down. I didn't see. Why does this time limit? I guess there's just a lot of entries, but and this set is pretty big. Okay, I'm gonna take a quick 1 minute break to use the restroom. I've been drinking too much iced tea. Be right back. And in the meanwhile, I'll still kind of think about it. Yeah. Hello. Hello, I'm back. Okay, so I think what I have to do now is figure out a way to handle. I mean, I think this is just too costly per intersection because the way that the worst case is essentially this set intersection is the entire the entire word list, which could be very long. I don't actually know. Maybe I could print that out actually just for a second. And doing this set intersection per query, which is possibly O of n, is too expensive, so we have to kind of reduce this a bit, which we have to think about. Okay, so this, I guess this is what I expected. So now I have to pre-calculate this. So what I'm thinking right now is try to think of a way that that we don't need the entire list of rates, right? Because maybe it's not strict. I don't know how far it goes, but if the prefix set is 15,000 entries and then they just ask the same thing many times, yeah, it's not great. I'm wondering also if there's one thing I might consider is just memorizing some parts of this, but I don't know if that's in the spirit of things. But in the sense that that's kind of like catering your code to specific inputs versus like a general solution, which is why I hesitate to do something like that specifically. But unless I could prove that it is, at least convince myself that it is true in a more general sense, because, for example, if we have 15,000 words, maybe we could do some like assume some balance type things, but I think I would say one of my original assumptions is that yeah, I think there's something I can do. I think one of my original assumption, which I don't know why I necessarily think that is that a word cannot be duplicated. Um, and if that's the case, each root. No, I don't. I don't know if that helps enough. Because so my idea was that we could remove duplicate words because you could just take the but like you could just take the last couple of entries and that should kind of be a good enough proxy. But then in that case, you can actually just have something similar to this, but except for there are 15, given the 10, like you could have a prefix that all have just the letter A, right? And that'll still return pretty much roughly everything. So I don't think that solves it per se. Is there a way we can store less than all of the possible weights and then do a set intersection? This is definitely faster than naive algorithm. Well, I guess this is a degenerate case in the sense that it is just as bad as a naive algorithm, and you could construct an equally bad case anyway, because the naive algorithm would do this in O of n times per f query, but instead we got it down to O of I mean, in theory, it's the number of characters in the prefix and suffix, but the sentence section is making this O of n. Maybe we don't need to set intersection though. Maybe we could count backwards. No, because no, yeah, we could. Okay, I think what I want to do instead of having a set is actually have a heap, and then we walk. We do a because here we're looking for the max in the set intersection, which you can do in a faster time, but maybe still worst case of n, because if the center section is nothing, then it still goes through both entire lists. So we might still have to think a little bit better than that. Yeah, because you could still definitely generate a case where that is. No, yeah. But there is some optimizations I can make, but I'm just trying to think if like that's sufficient for all of it. I think, yeah, maybe you also don't need set. I think one thing we can note is that maybe set is just a little too slow. And because we do them in order, this should be okay. Maybe that's what I need actually. Except for this part. Now you have two arrays, and you want to start from the bottom. Yeah. Yeah, you don't even need a heap sort because a heap thing because it's already sorted because we add them in order. Okay, so then now we can do something like please. What am I doing? If this is the case, then that's definitely a better optimization. I know it's sufficient. Oh, that's much faster. Is it sufficient? Yeah, I guess we'll see. I mean, it makes to set intersection.org, and but I guess it gives you a wrong answer, which is not as good. Okay. Is my assumption true? Well, I do add them in rate order. So we can always sort in either case. Oops. Oh, that is the right. What? How did I copy this? How did I copy this last time? How did I get this input? Okay, at least it's consistent. Recurring. This for the query. This. Doesn't even, no, well, it returns 0, which is, I guess, true. Wait, no, it isn't. That's not a proper suffix. Did I choose the wrong one? Oh, wait, I'm looking at the wrong things. Okay, this one. Oh, clearly this is wrong. Do I not clear stuff? Alright, that's peculiar, but maybe that I have a typo somewhere. So that's the first one, and then there's that, that's right. Oh yeah, why does this... Okay, so the array is right, but I'm doing the thing wrong. I'm not a smart nerd. Returning the point instead of the actual answer. Okay. What a silly mistake, and also that it worked for the exam. I guess the exam was not that good, but I had another test case. Oh no, I guess the other test case is from the time that we won and not the one that I had earlier. Okay, so that looks good. What a silly mistake. That's hopefully. Okay, cool. What can I say about this? Yeah, I mean, I think I mean, overall, you've been here with me while I was doing this farm. I think I enjoyed this farm. It's, I mean, some of it is that maybe yeah. I mean, it tells you the number of queries it can do. So maybe I should have done the math on that. I think I was a little fixated in the pre-processing part, in which we kind of scope out the space complexity, and but we did not. Well, I think some of it was that, like, excuse me, I changed the code to, instead of holding the weight in the node, I changed it to hold a set. And making that change was a non-trivial change that I did not analyze the complexity for, and I just didn't even think about it that much, which I probably should have been more careful about. I think what a set is, using a set is sufficient in the sense that it is correct, but it is not sufficient in the sense that it's once fast enough, because as we kind of talk about, we have to do a set intersection, which is over n, and just get the max intersection, right? So you only need to, and having this two finger approach allow us to kind of get it to the right way, because most of the time it's either yeah, most of the time it'll match very early. So even though it's still O of n and the complexity is still the same, it returns way earlier. Though it's kind of sketch in the sense that I feel like I can construct a time limit example for how I did it. So I don't know if there's a better expectation than kind of the way I did it. Because the worst case scenario for what I've done was that this gets returned -1, and each of these goes through half the array. So then you have like so it still goes through the entire thing. If like, yeah, if like, I don't know, if prefix matches everything and suffix matches nothing, or like one item or something like that, then it's going to go for the entire array. So it'd still be slow, and it's possibly still timeout, but for this set of input cases, it seems okay. Now let me know if y'all have any questions. But yeah, so it's in interviewee. I think there's still a little bit like I don't think I have a lot of clarity or confidence into this being the sufficient generic solution to this problem. I'll probably have to do some research later. As an interviewer, what do I think about this? I mean, I think initially I did underestimate this to just be essentially be an implementation of the prefix tree or the try. Uh, and apparently there's a set intersection in there, kind of, but not really. Uh, so I don't know. I guess I kind of dig it. I think I don't know if I would expect this kind of problem to be on an interview, but if it is, then I need to be prepared for it. I think this is, in terms of difficulty, probably on the right. Uh, I mean, I would have to play around with calibration, but I think that's probably on the like reasonable side of the difficulty. Okay, cool.